If you have a signal with you, like I have u of t, this is u of t. U of t is a signal. Its definition is the amplitude of the signal is 0 for all the negative values of time, but the amplitude is 1 for all the positive values of time. This is a signal u of t. Now on this u of t, I want to perform some operations. I want to play with the signal. I want to change all the different parameters of the signal. And before that, let us discuss what are the different things which you are observing in a signal. If this is the signal x of t, in this, if the time period is one time period, then in the one time period I have one cycle. This is the signal is starting here, increasing, maximum value it reached, and again decreasing. It keep on decreasing, and after some time, after reaching the particular value, it is again increasing. So this is called as one particular cycle. So in one time period, how many cycles are there? That is called as frequency. In one cycle, in one time period, how many waves are there, or how many cycles are there? One wave. This is one complete sine wave. One cycle of sine wave. Then the frequency is 1. If I have two sine waves in this, say something like this. If I have two sine waves in one time period, then the frequency will become 2. If there are 4, frequency is 4. If there are 8, frequency is 8, like that. So that is about the frequency. Now coming to the amplitude. So see this signal, the one which is in blue color, is having a maximum value here. Similarly, the opposite value, if it is some k, this will be minus k. So this value is called as the amplitude. Amplitude of the signal is said to be k. But you can see here amplitude is increased. It is increased. We can, if you want, you can put it more. You can increase more. You can increase amplitude. You can decrease amplitude. So such kind of things we are going to see in these operations. Operations are nothing but you will just work with the signals. You can increase the amplitude. You can decrease the amplitude. You can increase the frequency, decrease the frequency. Such kind of things we are going to see in the operations. So operations of x of t. So operations which we are going to perform can be an operation which is on this independent variable, operations on independent variable, I want to change this t. I would like to do some changes to this t independent variable. Or the other type, operations can be on, operations on amplitude. So two types of operations we can observe. So first we will see this category. What are the operations on the independent variable time? So they are, if I replace this x of t with x of, if I replace this x of t with x of t minus k, if I replace x of t with x of t minus k, then the signal is said to be time shifted. I am working with time, I am changing, I am doing some changes, some operations to the time. So such operation which I am going to perform on the signal are called as time shifting operations. So look at the signal. We have u of t with us. If I perform the time shifting operation on this, if say for example I want u of t minus 2. This is origin. Originally signal is starting at origin 1, 2. Signal is delayed by 2 units. So this is your u of t minus 2. If you, what did I do here? In the place of k, I kept a positive value. But in the place of k, if I keep a negative value, then what happens? Then this signal will become u of t plus 2. Actually, it is supposed to start at 0, but it is starting at minus 2 only. It is just like my class is supposed to start at 10 o'clock, but I am starting it at 9:30. Advanced. I am supposed to start at 10 o'clock, but starting at 10:30. So class is delayed. So this time shifting operation will give us signal delay or signal advance. So this is delay operation and this is the advance operation of a signal. So this is one operation which we are going to perform on a signal. Second one is, if I replace this x of t with x of minus t. Here I replace x of t with t minus k, but in this case I am replacing x of t with x of minus t. Then what happens, we will see. All operations we are performing on the input signal. You have to look at input signal, what is happening here. Look at the input signal, what is happening here. So for this, look at the input signal and I am changing the value from u of t to u of minus t. Earlier signal was defined in the positive axis. It was amplitude is 0 in the negative for all negative values of time, amplitude is 1 for all positive values of time. But because of this change in the independent variable from t to minus t, signal will become like this. It will become like this. So this operation is called as time folding operation. I am folding the signal. Where what is the transformation happening? Transformation is happening on the time. So this is called time folding operation. And coming to the third one, if I replace x of t with x of 2t or x of t by 2. If I replace t with x of 2t or x of t by 2, then what happens we will see here. For this, taking input signal, I will change the input signal from this unit step to a rectangular function. I will explain that here. I will take a new input this time instead of unit step. I will take this as the input. This is from minus 2 to 2. It's a rectangular function or a gate function. So in this, what I will do, this is, we will call it as x of t. I will apply transformation x of t by 2. So for this signal will change to, this will change to minus 4 to 4 instead of minus 2 to 2. So this operation is called as time expansion operation. Time was from minus 2 to 2 only, but now by changing this t by 2, it became minus 4 to 4. My class is supposed to be only 1 hour, but because of this change in the independent variable t by 2, it became 2 hours. So like that, time is getting expanded. This is called time expansion operation. Similarly, if I draw x of 2t, then this will become time compression. It will become minus 1 to 1 only instead of minus 2 to 2, because I am changing the independent variable from t to 2t. So like that you can obtain different operations on the independent variable. I am changing only independent variables. I am performing some operations on independent variable. Shifting is happening here. Right shift, left shift, delay, advance. I am changing independent variable t to minus t. Signal is getting folding. I am changing independent variable from t to t by 2. Signal is getting expanded. Changing t to 2t. Signal is getting compressed. Like that, we are performing different operations on independent variable. Now coming to the operations on amplitude. If you take another signal, something like this, u of t, if I want to change the amplitude, what is called amplitude? The operation which we are going to see an amplitude is called as, first one is amplitude scaling. It is amplitude scaling. In this is called time shifting. This is time folding. This we can call it as time scaling. We are changing time scale from minus 2 to 2, it became minus 4 to 4, or from minus 1 to 1. So this is called time scaling operation, but whereas this is called as amplitude scaling operation. So in the amplitude scaling operation, x of t is getting changed in such a way that it is getting multiplied by some value to that x of t. So originally my input is like this, having amplitude 1 unit step, but if I take 2 into u of t, 2 u of t, then this will become, amplitude will become, instead of 1 it will become 2. That means amplitude is increased to 2. Let me draw it clearly here. So instead of the amplitude 1, now this time the signal became 2. This is u of 2 into u of t. So amplitude was originally it is 1 only, but after scaling it became 2. Such an operation is called as amplitude scaling. And in this category, in amplitude scaling, we have few more. One is addition, subtraction, multiplication, division, differentiation and integration. If I want to perform addition, then I require two signals. So I will take signal 1 as x1 of t. Just I will perform addition with the operator plus, same like any normal mathematical addition, but how we will do that is we will do sample by sample. If I want to add this signal to this signal, I will check what is the value at origin here, what is the value at origin here, I will add both of them. Similarly, what is the value at -2, what is the value at -2, I will add both of them. Like that, I will add sample by sample in this, all the samples I will add in both. Similarly, I will do subtraction with by changing plus to minus. I will perform multiplication and I will perform division on the given two signals. And coming to the differentiation and integration, it is same like in any other mathematical operation. Just we will take d by dt of the given signal x of t, integration of x of t. So these all are the operations which will fall under the category operations which are transformations which we are going to perform on amplitude, the transformations which we are going to perform on independent variable. So that is about operations on signals.